Let's open up a neural network and see what is really inside. The name sounds like a brain, but inside, it is not a brain at all. It is just numbers. Numbers go in, they get multiplied and added inside, and new numbers come out. That is the whole idea. The smallest part is one neuron. Think of it as a tiny calculator. A few input numbers come in from the left. Each input is multiplied by its own weight. A weight just says how much that input matters. A big weight means push hard. A small weight means barely listen. Then the neuron adds them all up and adds one more number called the bias. The bias lets the neuron lean yes or no before it even looks. So a neuron is really just a weighted vote. It weighs the evidence and leans toward a yes or a no. And here's a nice surprise. One neuron like this, that squashes its vote to a value between 0 and 1, is exactly the logistic regression you may already know. Now put many neurons side by side. This is called a layer. They all read the same inputs, but each neuron learns to look for a different thing. One may watch for size, another for price, another for risk. Together, the layer turns a few plain inputs into a richer set of clues. Stack these layers, one after another. This stacking is what the word deep really means. Each new layer reads the layer before it, not the raw input. For a photo, the first layers find simple edges. The next find shapes. Later ones find whole objects, like a face or a cat. Simple ideas build into complex ones. But there is a hidden trap. A plain neuron can only do straight-line math, and stacking straight lines only gives you one bigger straight line. It is like stacking flat sheets of glass. The pile is taller, but it is still perfectly flat. No matter how many layers you stack, the network stays simple and cannot learn curvy patterns. The fix is a small rule added after each neuron, called an activation function. It lets each neuron bend the line. One bend may be tiny, but many small bends across many neurons can wrap around almost any shape you can imagine. This bending is the secret that makes deep networks powerful. Two activations are worth knowing. The first is the sigmoid. It takes any number and gently squashes it to a value between 0 and 1. Great for a probability. The second is ReLU, and it is even simpler. If the number is positive, keep it. If it is negative, turn it into 0. That is the whole rule. ReLU keeps a strong, clear signal for learning, so it became the favorite for the hidden layers in the middle of a network. Now let's put it all together and watch the network make a guess. The input numbers enter on the left. The signal flows forward, one layer at a time. Each neuron does its little vote, bends it, and passes the result on, until an answer pops out on the right. That single trip from input to answer is called the forward pass. Notice the network is only using what it already knows. It is not learning yet. For sorting things into groups, the last layer hands us a few raw scores. These raw scores are called logits, and they can be any size, even negative. Softmax turns those raw scores into clean percentages. The biggest score gets the biggest share. Every value is between 0 and 1, and they all add up to 100%. Now the network is not just guessing cat, it is saying, I am 90% sure it is a cat. Often we just want one final answer, not 3 percentages. So to decide, the network simply picks the tallest bar. That move has a name. It is called Argmax, which just means choose the option with the highest score. Here, that answer is cat. There is one last step. We compare the network's answer to the real truth. The loss is a single number that says how wrong we were. When the guess is close to the truth, the loss is small. When the guess is far off, the loss is large. Small loss is good, big loss is bad. This one number is the target the network will chase. The whole goal of training is to make this number as small as possible. So now you can trace a single guess from start to finish. Inputs become clues. Clues stack into ideas. An answer comes out, and a loss tells us how wrong it was. But how does that one loss number actually teach millions of weights to do better next time? That is the real magic, and it is called backpropagation. See you in the next one.